Today, we're marrying two powerhouses, Mongoose.WS, the ultra-lightweight embedded web server library, and the LilyGo TTGO T-Display board, to create a tiny, self-contained server you can hold right in the palm of your hand. So, what is Mongoose.WS anyway? Forget heavyweight frameworks. Mongoose.WS is a single C file with a header library, weighing at about 55 kilobytes flash and 80 kilobytes with TLS. It gives you HTTPS WebSocket, MQTT, TCP UDP, and TLS 1.3 all in one neat package. It's event-driven and non-blocking, so even resource-strained devices can juggle dozens of connections with minimal fuss. Companies like Bosch, Siemens, and yes, even NASA on the ISS rely on its rock-solid performance and years of bug fix love. It has an incredibly tiny footprint. You can drop the two files into your project and instantly get access to a full web stack. It has built-in security with TLS support right out of the box. And of course, it's cross-platform, no matter whether you're programming in Linux, Windows, or bare metal microcontrollers. Some considerations that you should keep in mind is that this is a C and C++ only project. So if you dream in Node.js, this project is not for you. It's dual licensed, either GPL v2 or commercial, so check your use case. And this is only a pure networking project. You will have to pair your own RTOS or file systems manually. Meet the LilyGo TTGO T-Display board. Under the hood is an ESP32 Extensa dual-core with LX6 microprocessor. This board is perfect for hosting because it has Wi-Fi and Bluetooth pre-built, ideal for Mongoose's networking magic. It's compact, portable, and battery power, which means no PC is required after the initial installation. Flash the Mongoose onto the TTGO T-Display board, and suddenly you have a full REST interface your phone or laptop can hit. You can set button presses to trigger events, toggle LEDs, send alerts, or even change server behavior. Its HTTPS interface, live controls, and zero external dependencies beyond these two files make it a real secure IoT node. This tutorial will go over an express installation of the Mongoose.WS. Call it an homage or an upgrade to the AQMS system we have just finished that uses the exact same TTGO T-Display board. In order for the installation of the project to work flawlessly, I suggest you go to espressif.com and install the ESP-IDF. After that, we will be heading onto the Mongoose.WS website and click on the blue button to start building our own web UI. We will create a new C project, select a wizard folder in which your build will be built, allow the edit, and of course, since we will be working with the ESP32, we will select the Espressif ESP32 series. You can see that this comes already pre-formatted for the build environment of the ESP-IDF. Click Next, and let's start with a blank dashboard. Finish. We will be creating two new pages, a settings page and a firmware update page. Now let's start with the dashboard. Over on UI elements, we will select a container and drag it in. After that, we will be adding a stats row. And here we need a device name, and let's say the RAM used, and the total amount of RAM on the device. Over in settings, we will be modifying the device name. And we will be setting the input as the device name. Lastly, in firmware update, we will be enabling the OTA upgrades. This is how our starter UI will look for now. This is supposed to be the fastest installation for the Mongoose wizard, and if you want, we can do a full dashboard development. Comment down below to let me know. As you can see in the info log, we have some missing API references. Let's set those up. Into the RESTful API, you can see that a firmware update has already been created automatically. We'll be adding some settings with a device name of type string, and let's set the default value to my device. You can see that the name also updated in here. We will be adding one additional API endpoint, and that's going to be state, in which we will be including the RAM used in RAM total. And of course, the state must be set to read only. We are now done with the configuration of our web interface. We will be creating the new code, and this will automatically upload the file into the selected folder. Now it is important to launch the ESP-IDF. I'm going to be using the PowerShell IDF. First, you need to navigate to the file. Now that we are in the specific folder, it's time to select the ESP32 as a target. Please make sure that your ESP32 is plugged into your computer via a USB-C or a micro USB before coming to this point. Now, to build the project so it can actually be read by the ESP32, all we need to write is idf.py build. After the code has finished building, we must input our SSID credentials. This is done in the main folder on the main C file. I am using Sublime Text as a code editor. In here, you must make sure to include your own Wi-Fi network and Wi-Fi password. After inputting our credentials, we can simply run the idf.py build command to start building our code. After it has finished building, you see that you have the flash instructions right here. We will simply run idf.py flash, and this will automatically select the ESP32 COM port. Once the flash is complete and code uploaded, let's open up a serial monitor to check on the IP of the device. And here we have the IP. And it seems like it links correctly to our web interface. But as you can see, all of the values are hard-coded from the API. Let's change that. In the Mongoose glue file, we can see that we have some API references from our web interface. It is time to set those up in the main C file. Of course, this will be done using our own callback functions. We will begin by adding a header for persistent flash storage. Now, right after Wi-Fi initialize, we will create a getState function. This will be retrieving the state with the total RAM used and the total RAM. After Mongoose init, we will be calling Mongoose set HTTP handlers to set up our own state handler. Since we want to store device settings persistently, in Flash, we will be adding a persistent storage handler. This will of course be accompanied by two functions, myGetSettings and mySetSettings, of course. These read and write to our settings structure. We have only one string set right here, device name. We can either save the whole structure at once or each member individually. In this case, we will be storing and setting each member individually. Of course, yet again, after Mongoose init, we will be initializing our non-volatile storage. And we will once again set up our own handlers using Mongoose set HTTP handler. Once this is done, save it and go back into your ESP-IDF. Close down the monitor if you haven't already. This is done by Ctrl-T, Ctrl-X, one after the other. And now we will be rebuilding this with the saved file. Once the build is completed, let's flash it onto the ESP32. But we will not be using the command anymore. Rather, we will try to use the web interface firmware update. In here, you should look for the firmware.bin file under the build folder. This will take a second. Go back to the dashboard, refresh the page a couple of times and see that nothing happens. That is because we should restart and reset our ESP32. Press the button on the side to reset it. We can keep tabs on the status of the ESP via the monitor. And it appears that the server is back on. Let's see. And it looks great. It has the device name of ESP32. which I had set previously, and I can see that we have a total RAM of 300,000 bytes. Well, there you have it. This has been the express setup of the Mongoose server. If you want me to go in depth with powering on LEDs or checking the temperature sensor of the ESP32, let me know down in the comments. So, if you're building compact IoT gadgets, edge computing consoles, or demo devices, this combo is a dream. Mongoose.WS for bulletproof networking, and the TTGO T-Display for self-contained, battery-powered server host, lean, secure, and utterly portable. This setup brings server in your pocket to reality. Give it a spin and let me know what clever applications you create.